Hello, I hope you're doing well. Today we're going to discuss packing and distributor overview. Tell you a little bit about KLM Technology Group, based in the US since 1995. We have associates in Australia, Malaysia, Indonesia, India, and the Philippines. KLM is a technical consultancy group providing specialized services and equipment to improve process plant operational efficiency, profitability, and safety. Our core business, training. We train companies all over the world, the Middle East, the US, Malaysia, Singapore, India. Engineering design guidelines. We're in our 18th year of engineering design guidelines, process optimization studies, process injury studies, HAZOP facilitation, siting studies, engineering support, basic design packages, detailed design packages, process equipment, random packing, structure packing, which we're going to talk about today, and distributors. Marketing, we have a engineering practice magazine that we've been publishing. Unit commissioning, been all over the world to start at plants, distillation equipment, inspection, correct installation, unit benchmarking, evaluation of process units. KLM provides process simulation. We do process simulations. Distillation hydraulics. KLM has our hydraulics. We use third-party hydraulics. One is called WellChem. We'll talk a little more about WellChem in this video. Unit troubleshooting, unit commissioning, training for your team, 30 years plus process engineering experience. One of our core businesses is process equipment. KLM is an EPC company, can purchase from many of the major equipment suppliers, tower shells, random packing, structured packing and trays, heat exchanger equipment, and pumps and compressors. Distillation equipment can be ordered with normal lead times or can be resourced for immediate replacement. KLM has a stock of random packing in Malaysia for immediate replacement. KLM has a stock of structured packing in Malaysia for immediate replacement. The shipping time should be short, and we also have some tray hardware in Malaysia, a stock of tray hardware in Malaysia. KLM buys a large volume of process equipment each year because we buy many heat exchangers, pumps, and distillation equipment for many end users. Many times our cost to the end user is lower than they can negotiate themselves because the end user may be only buying a few items per year and the vendor adds a large profit margin. Be sure and let KLM bid on your projects. We bid on a job and our competitor bid 100,000 and we bid 80,000 US dollars. And they were 20% higher than us because they felt like the end user had no choice. So we were 20% cheaper than the competitor. Be sure and let KLM bid on your projects. Let's talk a little bit about distillation in general, and then we'll talk about random packing, structured packing, and then we'll talk about some distributors. There are rules for which distillation device should be used based on pressure, flow, and fouling tendencies. For pressure, for high pressure applications, trays should be utilized above 150 psi, above 10 bars. Tray efficiency increases as pressure goes up, where packing efficiency decreases. There's a back mixing effect for packing at high pressure, so it's difficult to guarantee the efficiency at high pressures. Tray efficiency can be guaranteed at high pressures. For low pressure applications, 1 bar and vacuum system, packing has a much higher efficiency and can be guaranteed because you don't have this back mixing effect. So I had a young engineer and a vendor was guaranteeing packing at high pressure. And I said, no, he's really not guaranteeing it. Yeah. He told me he would guarantee this HTP. I said, well, call him in. Let's ask him. And so we called him in and he said, well, we expect that. I said, no, she understood that you we're going to guarantee it. So you need to put it in writing. Of course, he wouldn't put it in writing because there's this back mixing effect. And so she was very angry at the young gentleman because I'm pretty sure he had told her it was a guarantee. He told her verbally, but he wouldn't put it in writing. So be careful when you're using random packaging and structured packing in high pressure. You get lower than expected guarantees. Flow for pressure above 10 bar, use trays. If it's vacuum or low pressure, you almost use packing. For flow, high flow parameters, trays are preferred. For low flow parameters, packing may be utilized, may be preferred. Fouling tendencies. For a high fouling system, a well-designed anti-fouling tray is the best option. And I probably need to put one of these presentations together about what a good anti-fouling tray looks like. With proper distributors, and we're going to talk about distributors a lot today, structured packings worked well in refinery vacuum tower, which is a highly fouling surfaces. So you structured packing and very good distributors have worked well in one of the most highly fouling surfaces, which is a refinery vacuum tower. For fouling systems, random packing may be the last choice. I'll use trays first, I'll use structured packing, and then I'll use random packing last. Random packing has some horizontal components. So if one of the random packing is horizontal, it'll be a place where fouling can start. And so you may not want to use random packing in highly fouling surfaces. Let's talk about structured packing, advantages of structured packing, and we'll talk about advantages of random packing. So one of the advantages of structured packing is it is unique in that the top two layers act as a continuation of the distributor to distribute the liquid more evenly. So even if you have a bad distributor, which most of the distributors that I look at on the internet really are poor, and after this presentation, you'll be able to understand this. Structure packing is unique that the top two layers act as a continuation of the distributor to distribute the liquid more evenly. This results in excellent liquid distribution, leading to overall efficiency than random packing. Random packing does not have this top two layers redistributing. In offshore applications, there's a motion and tilt. This is important consideration. So if you have tilt, the liquid will start down one side of the column, and with structured packing, it will redistribute the first two layers. And we'll talk about this as you go further down the column. The liquid tends to go to the wall, and the vapor tends to go up the middle. So in very large beds, either random packing or structured packing, the last several meters are less effective, and we'll talk about this. Structured packing has very high efficiency in low pressure application. So if I have a low pressure application, trays are good. Structured packing might almost be better. All right. This equates to a high number of stages for the same higher height. So, of course, more stages, you can use less reflux, and you have energy savings. So if I have a atmospheric pressure or a vacuum system, I'm almost going to use structure packing. If I have very clean surfaces, I'm going to use random packing. Or if I have a very small diameter, I'm going to use random packing. Structure packing is a higher capacity in trays and low pressure applications. Equates to reduced tire diameters. Equates to higher operation rates in the same column. So if I'm limited, if I've got a crude column and I'm limited in a certain section of that column, say the diesel section is limiting the whole column, I can put packing in that diesel section and the whole column rates can come up. Okay. Structure packing, low pressure drop as compared to the trays, lower bottoms temperature, higher separation of difficult separates, low energy conservation, and less foaming. So there's several advantages for structure packing. Structure packing has lower fouling rate than random packing. There are no horizontal areas where the fouling can begin to multiply, longer run lengths, less residence time than trays. So for like styrene, which has a polymerization issues, in a styrene column, you'll add polymerization inhibitor. All right, so because you have less residence time, you have lower pressure drop, you have lower temperatures. Less polymerization inhibitor may be required in polymer fouling applications, particularly like in styrene. Structure packing has multiple styles. There's some made of sheet metal and some made of wire gauge, gauze. There are multiple textures of sheet metal. Some have holes and some do not have holes. The most common utilized is sheet metal with textured dimples to increase the wetting ability and small holes to increase the distribution. But typically looks like this. Invented in 1970, and so works very well. Atmospheric, low pressure systems. Doesn't have very many horizontal components, so it doesn't. It's fouling resistance. Structure packing is size based on the area, meters squared per meters cubed. All right. And there's a trade-off between capacity and efficiency for the different styles of structure packing. The number of theoretical stages per meter is an indication of the efficiency. The larger the area, the smaller the capacity, but the higher the efficiency. All right. So when something is very important and you're in a presentation, they tell you to put it in red. All right. So these number of stages per meter are is it atmospheric and vacuum pressures and very good liquid distribution. We're going to talk about what's a good liquid distribution. 90 would be okay. 90% coverage would be okay. You can get up to 95, okay? 95% efficiency of your distributor, all right? So a 200 area, which is 200 meters cubed, so it's got fairly wide openings. You might get 2 stages per meter, 250Y, which a lot of people use. You get 2.5 stages per meter, 350Y. It has a lot more metal, so it's going to be more expensive. It's going to have more efficiency, but it's going to have less capacity. 500 is going to have a whole lot more metal, so it'll be more expensive. Might have 4 stages per meter, but your capacity is going to be less. A lot of people will use 250 or 350. KLM has the ability to sell you 300. Okay, so if you're in a revamp situation and 350 won't work, we can actually make 300Y. Right. And this is in red. At atmospheric, our vacuum pressures, and very good liquid distribution. Packing works pretty well. It's the distributor and the bed heights that are what causes people problems. So we'll talk about that. There are 2 types of angles for the rows of the sheet metal, X and Y. X has a degree of 60 degrees. X has a lower pressure drop and higher capacity. May be used in high flow areas like pump around sections. Y has an angle of 45 degrees, is higher efficiency, but slightly less capacity. Y is utilized the most in applications. So 250Y is probably the most used type of packing. 1990s. Second generation structured packing was introduced in the 1990s. Has a straightened area of the interface between the layers of packing. Instead of the interface being at 45 or 60 degrees, the interface is matching. This simple change to the packing resulted in a 25% to 40% increased capacity at the same efficiency. Today, most new columns are utilizing second generation structured packing. So this was patented in the early 1900s, early 1990s. A patent is good for 17 years. So before 2000s, the patents ran out. So second generation structured packing has been open art since 2000. And it's the same roughly number of stages, but it has 25 to 140% more capacity. Second generation structure packing. So let's talk a little bit about random packing. Random packing has a low pressure drop as compared to trade applications. This equates to lower bottom temperature for heat sensitive products, higher separation, difficult separations, lower energy consumption, less foaming. For really clean service, random packing is excellent when you have a small column. Random packing is good. So these are places you should use random packing. Higher energy savings, higher number of stages. Again, in the top of a crude column, in the naphtha splitters, and there's certain relatively clean services where you could use random packing. Many styles of random packing. So by 1914, ratchet rings were developed. 1940s, Paul rings. 1970s, I-type rings. 1980s, improved Paul rings. Performance is based on style and size of packing. Newer generation will have higher capacity and efficiency than older generations. But again, we have the trade-off between capacity and efficiency. A 25 millimeter will have higher efficiency but lower capacity compared to a 50 millimeter 2-inch size. The I style may be the best from a cost and performance matrix. So if I'm going to choose, I'm typically going to choose an I style type of packing. So 1-inch might be 2.5 stages, and 2-inch might be 1.7 stages. So roughly for structured packing and random packing, low pressure, good distribution, you get about 2 stages per meter. That's just a good rule of thumb. Low pressure, good distribution, you get about 2 stages per meter. That's just about where you're going to be. Improved Paul ring, style H, improved Paul ring. These were all different years, different styles. So let's talk about bed heights for a minute. Okay. So, as you go down the bed, maldistribution increases. Maldistribution can reduce efficiency by 50%. So where you think you've got 2 stages per meter, at the bottom of the bed, you might only have 1 stage per meter. The liquid tends to move to the column walls, and the vapor travels up the middle, reducing the mass transfer. And again, there's this trade-off. What is the best bed height to install a collector and redistributors? All right, so the fewer the collectors and redistributors, the shorter the column, lower the capital cost. But the efficiency of the packing decreases, leading to higher operating costs. So there's a trade-off between CapEx and OpEx. All right, so I can put less recollectors and redistributors and have less capital cost, and have more energy. All right, so there's a trade-off between the two. The collector has 2 functions: to collect and mix the liquid from the bed above, and then to redistribute the vapor. Now remember, the vapor is going up the middle. All right. Some collectors in small columns actually do not redistribute the vapor very well, and there are multiple papers on this issue. So you got to be real careful in small columns that the collector doesn't disrupt the vapor flow even more. All right. So, and there's multiple papers on this. So I want to collect the liquid. I want to mix that liquid because it's got different compositions. So I want to collect the liquid, and then I want to redistribute the vapor. And there's been incidents where the collector has actually blocked the vapor. All right. And there's a whole range of papers on this. Then the distributor is to evenly distribute the liquid to the next bed. All right, so what are some bed general guidelines? In general, the guideline is do not exceed 15 theoretical stages. If a good assumption is 2 stages per meter, so you have about 7.5 meters or 25 feet. Today, many vendors are going to 10 meters, but you'll get limited mass transfer in the last 10 meters, in the last few meters. So you're probably only getting half the efficiency. You're probably only getting 1 meter per stage. Columns containing less than 5 theoretical stages per bed are relatively insensitive to liquid maldistribution. This would be a short bed of about 3 meters or 10 feet. All right, so you're looking at short beds. You really don't have to worry about the liquid maldistribution. With 10 or more beds, when you get up to 10 stages, so above 5 meters or 16 foot, maldistribution becomes an issue. All right, so if I'm building a column from scratch and it's not too high, I may go with 5 meters. All right. Many authors recommend that you not exceed, there's many authors and many papers out there. You do not exceed 3 meters for ratchet rings, or 6 column diameters, or 12 diameters for pawl rings. All right. So basically, because you use random packing in a small column, you don't, you start to get wall effects. All right. So you really don't want long beds in there. And the packing size should not be greater than 1/8 the column diameter. So I don't want to put big packing in a small column. I want you put small packing size in a small column. So these are bed heights general guidelines. Distributor quality. So I want to do a cost analysis on how long I want my bed. All right. So I've got a capital cost versus energy cost. All right. If I have more collectors, I've got more efficiency, I've got higher purities, but the more collectors cost me money. So I've got to think about that. Distributors, same thing. For packing systems, every designer will mention that the packing only works as well as the distributor. And then they normally provide a not optimized distributor. Good normal industry standard distributors average about 92% distribution quality, which is not good, but not bad. Below 90 is considered poor. Many are below 80%. 94, 95 is achievable. We'll have an increased cost. All right. So for structured packing, you can get away with a poor distributor. Don't know why you would want to, but you can, because the top 2 beds will help you redistribute. But you're losing the efficiency in the top 2 beds if you don't have a good distributor. If you search on the internet, you could see many distributors with very low efficiency. Many look below 80%. So when next time you look at a distributor, you think about the pattern of liquid that's going to be on that top bed of that packing. And you think about the percentage of coverage. Here's some pictures from our friends at Wellchem. They have hydraulic software and distributor software. All right, so here's a pan distributor. A pan distributor are not good for fouling services, because if you have fouling, the holes in the bottom will foul, and then you'll have even worse distribution. But they have medium quality distribution. If you look, you can see the rings, the circles of the holes, and you can see fairly large areas where there's no liquid there. This distributor might have 80 or 85% efficiency coverage. Okay. So I'm really not a fan of pan distributors. I usually don't use pan distributors. They're not good for fouling services, and they have a medium quality distribution, but they're cheap. All right. They're cheap. Here's a trough distributors. Typically, this is what I use. Notice the better distribution quality. All right. It's easily, this one's probably 90%. Okay. It could be optimized. It could come a little further to the wall. And so this is a okay distributor. All right. This is probably the minimum I'd want for random packing. I definitely wouldn't want a pan distributor for random packing. All right. And this is a deck distributor. It even has lower distribution quality. All right. So you're looking at this, it's got well below 80% distribution quality. All right. So of course it's cheap and of course you're not going to get much. All right. So if I put a deck distributor with a long bed, I've asked for troubles. I've asked for maldistribution. Okay. So KLM always KLM always tried to give good bed heights, and we try to give good distributors. For structured packing, the top two layers redistribute the liquid. Each layer is 300 meters. You have a 3 meter bed. You lost efficiency in the top two layers, which is 20% of the bed height. So even with structured packing, I'm gonna try to give you a good distributor. All right. I'm gonna try to give you this 95 distributor. All right. So you won't lose that efficiency in the top of the bed. Higher efficiency will save energy, reduce energy costs, give you higher purities of your products. For random packing, the packing will make some, but not like structured packing. It is more important for an optimized distributor for random packing to increase efficiency and reduce energy. I'm going to try to optimize the distributor design to gain as much distribution as possible to improve the packing efficiency, reduce energy, saves money. Energy is $4 per million BTUs in the US, and it's $15 per million BTUs in Asia. It does not take much energy savings to be real money. Okay, so an easy thing to do is go look at your distributors. From the pictures I've showed you today, you can look and tell whether you've got a good distributor or not. If you don't have a good distributor, you come to KLM and we'll build you a new distributor. Okay. And so distributors are not very expensive, and they will pay back in energy savings quickly. Quality suppliers, buyer beware. There are hundreds of random and structured packaging suppliers, some at very low cost. KLM only buys from quality suppliers that we embed in. Suppose you're buying random packing and the thickness is 0.3 millimeters. Low-cost vendor provides you a thickness of 0.28, which is difficult to measure. His raw material cost is 6% lower. If you have a large bed, the crush strength of the thinner packing is lower and the bottom of the bed might be crushed, leading to high pressure drop. So you saved money. Of course, he's deliberately bought thinner material, and his raw material cost is 6% lower. Suppose you're buying random packing and the size is 25 millimeters. Low-cost vendor might provide you packing with 27 millimeters, which is difficult to measure. Packing is sold in 1 meter bags. The bag should be full and weighed. Again, his raw material cost, by the packing being just slightly bigger, is 3 to 5% lower. All right, so he gets 6% on the thickness, he gets 5% here, he's got 10% lower cost. Larger packing will give you more capacity, but less efficiency. If your energy cost is low, this could have a large effect, but most companies do not have low energy cost. All right, so you need to make sure you're buying the right thickness. You need to make sure you're buying the right size. I talked to a gentleman last fall where he had been buying higher priced structured packing, and his suppliers, his purchasing team wanted him to buy the lower price packing, which he did. And then it lasted only half the time as the other previous packing. So I'm sure it was thinner, and it was probably the wrong size. And the other thing, it probably was the wrong metallurgy. Suppose you're buying random packing with higher metallurgy to decrease packing life, like you do in pommel. Low-cost vendor provides you packing of lower quality, which is difficult to see. Make sure you have a positive metallurgy identification machine. A PMI machine, you touch the machine on the package, on the packing, it confirms the metallurgy. Again, if he buys you lower cost metal, his raw material cost is 30 to 50% lower. All right. So even though he's 20, 30% lower, he's still making a large margin on you. So make sure you buy from quality suppliers. With energy in the US at $4 per million and $15 an age, it does not take much money to be real energy savings. And there's a good reason someone's packing is lower cost. May not actually save you money. KLM, make sure we buy very high quality packing that meet or exceed OEMs. Equipment installation. KLM can design and supply the very best installation internals. We can give you the best packing. We'll give you the best distributors. But if they're not installed correctly, the capacity and efficiency will be reduced. Many organizations do not have the experienced tower inspectors because they only enter the towers on a 3 to 5 year basis. KLM is happy to provide senior tire inspectors to assist your turnarounds and tire reviews. I'll send a senior guy that's worked with me a long time. If he's unhappy with something, I might even show up. Okay. And so we'll be happy to provide senior tower inspectors. KLM service technicians provide a valuable service to our customers by assuring that the distillation column's equipment is installed properly, meeting KLM's installation specifications. KLM service technicians are available to our customers need them anytime, anywhere. Inventory and mass transfer equipment, supervision of installation to meet the equipment specifications. So we can look at assessment of new and replacement equipment, existing mass transfer equipment, installation, expediting and troubleshooting, turnaround, and installation consulting. Column hardware, trays, different things can be ordered with normal lead times or can be sourced. We've got a stock of column hardware in Malaysia for immediate replacement. If you need some column hardware, we can deliver them tomorrow. Okay. If you're in Malaysia, we can probably deliver them in 2 days. If you're in Thailand, we can probably deliver in 2 days if you're in Indonesia. Over 20 distillation projects with multiple columns, over 40 heat exchangers, over 20 pumps, over 20 pressure vessels. Here's a tower we designed in Thailand. Here's a list of things that we've done. Petronas 2006, Thailand 2007, Malaysia 2007, ROC, BTX plants, 3D model review, tower design, facility siting, palm oil consulting, Formosa, hands off, numerous training classes. We provide process simulation, installation hydraulics, KLM, and our third party, unit troubleshooting, unit commissioning, training for your team, 30 plus years. Solid track record of projects, Southeast Asia since 2005, strength in process engineering, distillation equipment supply, heat exchanger pump supply, strong partnership, mechanical engineering, fabrication, wide range of services, ready to assist for your next project. Thanks for your time today.